Okie dokie. In this problem, we will be using the method known as separation of variables in order to identify a general solution y of t to this differential equation. So let's talk about the first step. We want to first rewrite, anytime we see y prime of t, just go ahead and rewrite it as dy over dt. So we'll have that equals 2y over t squared. Now the next step is to get the y terms on the left side and keep the t terms on the right side. So y terms on the left side. How do we get this to the left side? We want to divide by 2y on both sides. Another way to think about it is by multiplying by 1 over 2y on both sides. So on the left side, now we have 1 over 2y dy over dt, and then on the right side we will have just 1 over t squared. And now we just want to multiply the dt from the left to the right side, and altogether we should have 1 over 2y dy equals 1 over t squared dt. Now what we're going to do is integrate both sides. We introduce integration in order to find the antiderivative on both sides. Now, over here, where we have a 2y on the bottom, what I might recommend is, because we just have a constant 2 on the bottom, it's basically as if we have 1/2 out in front and then just 1 over y dy inside the integral. So when we take the antiderivative, we'll still have 1/2, and then we ask ourselves, antiderivative of 1 over y is what? This is where natural log comes into play. So the derivative of ln of y is 1 over y. And so the antiderivative of 1 over y is ln of y. And anytime we have ln as the antiderivative, we want to remember to put absolute value bars just in case. And then we do the right side. So we have 1 over t squared, and we want to find the antiderivative. So first thing I would recommend is rewriting it as t to the negative 2, just like we would taking the antiderivative in other problems or taking the derivative of this function, etc. So we have t to the negative 2. We want to find the antiderivative by adding 1 to the exponent. Negative 2 plus 1 is negative 1. And we divide by whatever that new exponent is. So t to the negative 1 over negative 1. Dividing by negative 1 is basically just calling the whole term negative, and then t to the negative 1 is the same as 1 over t to the positive 1. So just negative 1 over t all together. And then on the right side, every time we take the antiderivative of both sides, we want to add a plus c on the right side. Technically, you would have plus c on both sides, but to kind of absorb both constants, you can just do plus c on the right side every time. So now, our goal is to solve for y. We want to isolate this y on the left side. So how do we start? We want to get rid of this 1/2 by multiplying by 2 on both sides. When we multiply by 2 on both sides, this will cancel. We'll have ln of y equals, we could call it negative 2 over t plus 2c, basically distributing a 2 to both terms on the right side. And then we want to isolate y by eliminating natural log, which we will do by making e the base of both sides. And then in this case, you can sort of ignore the absolute value bars. It's a good habit to get into, like writing it for the antiderivative every time, and it might come in handy, but usually you'll be able to drop them later in the problem. So we can just drop them here. Y equals e raised to the negative 2 over t plus 2c, all in the exponent. So now let's see what options they have for us. Do we see any sort of negative 2 over t within the exponent of e? We do see e to the negative 2 over t in option B. And that's looking like our best answer. So let's talk about what else they did with this. We have the sum of two terms in the e exponent. What we can do is break this up with multiplication of two e terms with different exponents. Because if we went in this direction from the right to the left here, we would add their exponents when we multiplied the two e terms. And so we're breaking it up. We're going the opposite direction. And now e to the 2c is just a constant, because 2c is just some constant, and then e raised to that constant is just some constant. So really, if we wanted to, we could call that c. And so what they've done is brought that c out in front of the e term. So flip-flopping these, they've just thrown c out in front to give us option B as our answer. And that's pretty much it. All right, let's go and do one more example using separation of variables. Starting with rewriting the left side as dy over dt, we have 7t cubed times y. We want to divide by y in order to get it on the left side, or multiply by 1 over y, however you want to see it. We have 1 over y, dy over dt equals 7t cubed. And then we just want to multiply the dt from the left to the right side. And now we have 1 over y dy and 7t cubed dt. Next step, integrate both sides, finding the antiderivative of both sides while adding plus c to the right sides. So 1 over y has an antiderivative of natural log of the absolute value of y. Antiderivative of any power function, we add 1 to the exponent and divide by whatever that new exponent is. And the 7 is just a coefficient, and so it stays out in front. And that's pretty much it. Now we want to get y by itself by eliminating natural log, by making the base of both sides e. So now we just have y is equal to e to the 7t to the 4th over 4 plus c within the exponent. And again, you could break this up as e to this power times e to the c, but e to the c is just another constant. So they've just multiplied by that constant out in front. So ce to the 7t to the 4th over 4 looks like option 8. And that's it. All right. Hope these examples helped. If you have any questions on any antiderivatives or any part of this process that was unclear, please let me know. All right.